Today's lesson is on the Pythagorean theorem. The Pythagorean theorem is something that you may have learned in middle school, so if you did, hopefully this is just a review. The Pythagorean theorem applies to right triangles only. This here is a right triangle, as long as we have an indication that we have a right angle. We have a hypotenuse, which is always across from the right angle. And we have two legs of the triangle. So many times teachers teach the Pythagorean theorem as a squared plus b squared equals c squared. I generally teach the Pythagorean theorem as leg squared plus leg squared is equal to the hypotenuse squared. And the reason why I teach it as leg squared plus leg squared is so that you don't have to know which one is A versus which one is B. They are interchangeable. They are both called legs. So add your two legs together, and that's equal to your hypotenuse squared. I'll put a note under it that sometimes it's a squared plus b squared is equal to c squared. Okay, so because this is probably a review to many of you, I'm going to teach the first example in each set. And the second example, I'm just going to go over without talking, and you guys can follow along and see my work. So for the first one, I'm going to take a moment and label my parts. So I see that I have a right angle, which is good. This is called my hypotenuse. This here is a leg, and this here is another leg. So my formula is leg squared plus leg squared equals the hypotenuse squared. When I substitute in these values, I'm going to substitute in 20 squared plus 21 squared is equal to, we're looking for x squared, which is the hypotenuse. That's what we're solving for in this first example set. So 20 squared is 400. 21 squared is 441. And this is equal to x squared. We add these two numbers together. 841 is equal to x squared. At this point, you take the square root of each side, and you only take your positive value as your answer. So what is the square root of 841? And the correct answer would be 29. That means your hypotenuse is the length of 29. Now, if by chance this was not a perfect square underneath the radical sign, you of course would have to simplify it like we did last class. Please follow along as I complete example 2, or if you would like to try it by yourself, press pause on your screen and complete it alone, come back and check your work against mine. For the next example set, we're finding a missing leg length. So notice how here we have the hypotenuse, we have a leg, and we have a leg. So now we're missing this length here. And missing or solving for a missing leg is a bit more difficult. It adds one extra step to our solving process. So our formula is still leg squared plus leg squared equals hypotenuse squared. The first leg length I'm going to use or represent with x. So x squared, that's this one here, plus 8 squared is equal to the hypotenuse of 20 squared. And now I need to solve for this. So we have x squared plus 64 is equal to 400. You are solving for x, so we need to isolate x. That means I am subtracting 64 from both sides, leaving me with x squared equals 336. I'm going to take the square root of both sides, and 336 underneath the square root is not a perfect square, but it does have a square factor, and its square factor is 16. So I can write this as x equals the square root of 16 times 21. And I know that the square root of 16 is 4, so my final simplified answer is 4 times the square root of 21. And this is how I want your answer. If you type that into a calculator and give me a rounded value, I am going to take points off for that. I need your answer in the simplest radical form. That's why we spent last class going over how to simplify. Okay, again, follow along as I go through number 2, or take this time to try it on your own and come back and check your answer. Next, we have Pythagorean triples. So Pythagorean triples is a set of non-zero whole numbers that satisfy the equation of leg squared plus leg squared equals hypotenuse squared. So they're numbers that work out perfectly. For example, 3, 4, 5. So 3 squared plus 4 squared is equal to 5 squared works out perfectly. Okay, you don't end up with a square root that you had to simplify. You don't end up with a decimal. These numbers work out to be a perfect answer. This would be 9 plus 16 equals 25, which is true. Another example set could be 5, 12, and 13. Another one could be 8, 15, and 17. And the list continues. So when you're looking at Pythagorean triples, the largest number is always going to be your hypotenuse. Right here, this extra note says if you multiply each number in the Pythagorean triple by the same whole number, the three numbers also result in a Pythagorean triple. That means if you take these values and you multiply every number by, say, 2, that is also going to create a Pythagorean triple. Anyways, we'll get to more of those examples later, but let's scroll down to the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem states that if the square of one side of a triangle is equal to the sum of the squares of the other sides of the triangle, then the triangle is a right triangle. So you're proving that your triangle is a right triangle. And I want everyone to make a note that the longest side would represent the hypotenuse. Now, it might not be a right triangle, so it might not be the hypotenuse, but if anything is true, it's that the longest side would represent the hypotenuse. In number 1, we have side lengths of 5, 6, and 8. I'm going to label 5 and 6 as a leg, maybe, because we don't know if it's a right triangle, and 8 as the hypotenuse. Again, maybe, because we're proving if it is or if it isn't a right triangle. So when I substitute this into my formula of leg squared plus leg squared equals hypotenuse squared, I'm going to substitute in 6 squared plus 5 squared equals 8 squared. When I simplify that, I have 36 plus 25 is equal to 64. Well, 36 plus 25 is 61, which is not equal to 64. So you would say this is not a right triangle because of this right here. You proved that it is not true. So not a right triangle. It has to come out to be true in order to be a right triangle. And number 2, press pause, try this by yourself. Remember that the longest leg is always the hypotenuse. I'm just going to make a note that 85 is the longest side. So try substituting these 3 numbers into the formula and determine, is this a right triangle? And the last part of the notes works off of our last section. So suppose you end up with something that is not a right triangle, such as example 1, where you can see our answer right here. So if that's the case, you have 3 options. Well, the first option is a right triangle. If your formula works out to be true, then you would say that yes, you in fact have a right triangle. But let's say your 2 leg lengths add up to a number that's greater than the hypotenuse. This would show that you have an acute triangle. Or what if your leg lengths add up to be a number that's less than the hypotenuse? That would prove to be an obtuse triangle. Okay, if we're looking at this example above, it appears that our 2 side lengths of 36 and 25 added together to give us 61, and 61 was less than the hypotenuse squared. So in this example, this would be an example of an obtuse triangle based on this chart right here. Let's take a look at the last 2 examples together. Remember that you're always substituting the longest side in for the hypotenuse. In number 1, we have 6, 11, and 14. This would be 6 squared plus 11 squared, and we want to know, is this equal to, we don't know, 14 squared. 36 plus 121 is some relation to 196. 36 plus 121 is 157. This number is less than 196. So this triangle would prove to be an obtuse triangle based on our description above. The reason why I know it's obtuse is because this number is less than this number, which falls under this category. And lastly, we have side lengths of 30, 40, and 50. So 30 squared plus 40 squared equals 50 squared. This is 900 plus 1600 is equal to 2500. 900 plus 1600 is 2500. So this comes out to be true, which is in fact equal. So we would say that this is a right triangle. Okay, so that's it for the notes. Please let me know if you have any questions and complete your Go formative. Have a great day, everyone.